Good morning, guys. Once again, we are back. A very warm good morning. So, welcoming you all to yet another super awesome session from BioPoint, Stream the World of Bio. And hope you all are perfectly ready for the session. And let's do it with the today's session, a one short session on breathing and exchange of gases. Hope everything is perfectly fine and you all are ready for this session. Okay, then, so let's move with this session. And before moving on to the session, reminding you to join the Telegram group where there is daily session updates, regular discussion, interact with me, daily polls, and the direct link to join the Telegram group is t.me/neat_biopoint. And once again, reminding you, do hit the like button, do share it with your friends, and do subscribe the YouTube channel BioPoint, Stream the World of Bio, and remark us by giving a comment in the comment section. And the world of Bio is open here for the sweet 10th batch, 11th, 12th, and for the repeaters batch. And now we have started the bridge course for 2023 NEET batch. So hope you all are perfectly ready for this session. So let's move on with today's session. So starting with the human respiratory system, that is the air passage is the first topic. So before moving on to that, let's have an introduction. Hope this screen is perfectly clear for you without any blur issues. I hope this screen is perfectly clear. Okay, so let's start it. Yes, Calvin. Good morning. So before moving on to this topic, let's start with something else. That is, what is breathing? What is our topic? Chapter name: breathing and exchange of gases. And what is this breathing? Breathing means it is a simply intake of oxygen, that is simply intake of fresh air or the oxygen from the atmosphere, and the removal of foul air, that is the carbon dioxide produced by the cells from the body, and that is what is said to be breathing. And what is respiration? Respiration is the environmental, that is the exchange of environmental oxygen with the carbon dioxide produced in our body after metabolic activities, that is during the oxidation of food. And that is what is said to be the difference between breathing and respiration. Respiration refers to the oxidation of food, whereas breathing is just the exchange of gases. Clear? So moving on to the next topics, that is the air passage, starting from human respiratory system air passage. So if an air enters into our nose, through what way does the air moves to our body to the lungs? That is what we are gonna learn now. So that is, it enters the external nostrils to the nasal passage, to the nasal chamber, pharynx, glottis, larynx, trachea, primary bronchi, secondary bronchi, tertiary bronchi, bronchioles, terminal bronchioles, and alveoli. This is the passage. This is the correct order or the sequential order of the passage of air when entered into our nostrils. Clear with that? Clear with that? Okay. So look, the air moves on to the external parts, the nostrils, nasal passage, nasal chamber, pharynx. Till there, it's not shown. Till glottis, it's not shown. And after that, it moves on to the larynx to trachea, right? Larynx to trachea. From then to the primary bronchi, then to secondary bronchi, then to tertiary bronchi, and finally to further bronchioles. Look here, further bronchioles. Okay, and in the terminal bronchiole, you have certain grape-like structures called as alveoli. This is the exact passage of air. Okay, guys. Okay. Oh no, I'm not at all getting your chats. I think now no one is here. So the epiglottis closes the glottis to prevent the entry of food into the larynx. So there is a structure known as epiglottis. That is a flap-like structure. A flap-like structure in order to prevent the entry of food into the larynx. Okay, clear with that? Next is the lungs. So lungs are covered by a double-layered pleura. Alveoli are the structural and functional unit of lungs, and the instrument used to measure the respiratory rate is the spirometer, and the normal respiratory or breathing rate is 12 to 16 times per minute. 12 to 16 times per minute. So where are these lungs situated? They are situated in the thoracic chamber. Okay, Calvin. They are situated in the thoracic chamber. The lungs are situated in the thoracic chamber. The lungs are situated in the thoracic chamber with anatomically an airtight chamber, which is anatomically an airtight chamber. And what's next is that certain structures called as intercostal muscles, diaphragm, and all are the supporting structures for this lungs that helps in or that functions during the inspiration and expiration. So how what is this thoracic chamber formed of? What we say that the lungs are situated in the thoracic chamber. So what does this thoracic chamber formed of? This thoracic chamber is laterally formed by the ribs, laterally by ribs, ventrally by sternum, ventrally by sternum, then dorsally by vertebral column, dorsally by vertebral column, and the lower side of the thoracic chamber by a dome shaped structure known as diaphragm. This is how the thoracic chamber is formed. The thoracic chamber is formed laterally by the ribs, ventrally by the sternum, dorsally by vertebral column, and the lower side by dome-shaped diaphragm. Lower side by dome-shaped diaphragm. This is how this thoracic chamber is formed of. Hope it's perfectly clear till now. Hope it's perfectly clear till now. And moving on. Okay. Mechanism of respiration or mechanism of breathing. Mechanism of breathing. Okay, Calvin. So breathing involves two processes. The first one is the inspiration. First one is the inspiration, and second one is the expiration. Second one is the expiration. Okay. So what is this inspiration and expiration? What is this inspiration and expiration? So these are the two stages involved in breathing. So what is this inspiration? Inspiration means the air moving inside the lungs. The process by which the atmospheric air is drawn in. The atmospheric air is drawn in, it is inhaled into our body, and expiration is the process by which the alveolar air, not the atmospheric air, now expiration we are using the term alveolar air, is drawn out, is released out. Alveolar air is released out. Hope my writings are clear. Okay, so So when does this inspiration occurs? The inspiration can occur when the pressure within the lungs. So what is this pressure within the lungs known as? Pressure within the lungs. What is this pressure within the lungs known as? Comment me right now, guys. Comment me right now. What is this pressure within the lungs known as? Pressure within the lungs is known as the intrapleural pressure. Intrapleural pressure. Intrapleural pressure. Okay, Calvin? Very sorry. Very sorry. Very sorry. Very sorry. Intrapulmonary pressure. Intrapulmonary pressure. Okay, fine. So when this intrapulmonary pressure is less than the atmospheric pressure, so intrapulmonary pressure is less than atmospheric pressure, this inspiration may occur. And what happens when this inspiration occurs? When inspiration occurs, the dome-shaped diaphragm and the external intercostal muscles contract, the thoracic volume increases, the pulmonary volume increases, the intrapulmonary pressure decreases, and the air moves into the lungs. This is what the mechanism happens when inspiration occurs. Is that clear, guys? Is that clear? So air moves into the lungs during inspiration. Ribs and sternum are raised. Volume of thorax is increased. Rib cage, that is the external rib cage here, just meant to show the external intercostal muscles. They all contract along with this diaphragm too. The dome-shaped diaphragm contracts. Is that clear? Is that clear? Next, what we are going to learn is expiration. So, expiration occurs when the same intrapulmonary pressure is greater than the atmospheric pressure. Expiration occurs when intrapulmonary pressure is greater than the atmospheric pressure. Okay. So, what happens when this expiration takes place? Expiration means what? The alveolar air is drawn out. This is A, okay, drawn out. So during that time, what happens is that the intercostal muscles and the diaphragm relax. Thoracic volume decreases. Pulmonary volume decreases. Intrapulmonary pressure increases. And what happens is the air moves outward. This is what the mechanism occurs when the process of expiration takes place. Is that clear? Is that clear? Okay, fine. So let's move to next. Yeah, before moving on to next and before telling about this, let's do something else. My god, it's not at all working. The screen. Right screen. Okay, fine. So let's have a recap. So let's have a recap of what we have learned till now. That is the inspiration, the mechanism occurring during inspiration. Yes. So inspiration, the first one is air entering lungs. Air entering lungs. Second one, ribs and sternum. Ribs and sternum raised. Third one, volume of thorax increased. Volume of thorax increased. Fourth one, diaphragm contracts. Diaphragm contracts. And this is the entire mechanism of inspiration. Is that clear till now? Is that clear till now, Calvin? Is that clear till now? And next, what we are going to learn is about expiration. What all happens during expiration? What all happens during expiration? So let's check it. What all are the things that are going to happen in expiration? The first one, that is air expelled from the lungs. That is the alveolar air is released out. Air is expelled from the lungs. Second one, ribs and sternum. About ribs and sternum is the second point. Ribs and sternum returned back to the same position. Returned back to the same position. The third one is volume of thorax decreased. In case of inspiration, the volume of thorax increased, and here the volume of thorax decreased. And the fourth one, diaphragm gets relaxed and comes back to its dome-shaped position. That is, the diaphragm gets relaxed. Clear with that? Clear with that? Okay, Calvin. So, and now what I am gonna remind you is that on February 8, 2021, this month, the 8th, that is this Sunday, that we are gonna have the weekly revision marathon. Let's do it. So all of you just stay tuned for that. We are gonna have it with a question discussion, and I need maximum participation in that. So each and everyone watching this session, do support this. Okay, then moving on to next, that is the respiratory volume and capacities. So what is this respiratory volume? What is known as respiratory volume? The quantity of air. Oh, you can't see. Very sorry. Very sorry for that. So the quantity of air the lungs can receive. Where is this? The quantity of air that the lungs can receive, hold, or expel. Three terms are given here: receive, hold, or expel. So the quantity of air that the lungs can receive, hold, or expel under different conditions is known as what? The respiratory capacities or respiratory volume. Okay. So the first one is the tidal volume. What is this tidal volume? The volume of air inspired and expired during a normal breathing or a normal respiration without any effort, that is known as tidal volume. So the normal volume of air inspired or expired is known as this tidal volume, and it is about approximately 500 ml. It is approximately 500 ml. Approximately 500 ml. So just note this values or the volume of tidal volume given for the specific respiratory capacities. Okay, guys. So just mark it or just bookmark, just note it down. And what you have to do is, when after completing this topic of respiratory volume or capacities, we are gonna write these values separately in a paper or a page. Okay, we are going to write this separately in a page about the value of tidal volume. What is its value? Approximately 500 ml. Like that, we are going to do it. So just note it down so that you may comment it right when I ask you. Second one is the inspiratory reserve volume, that is the IRV. That is the additional volume of air that a person can inspire by a forcible inspiration, a forceful inspiration or a forcible inspiration that. Okay, Calvin. Okay, fine. So 2500 to 3500 ml. Okay, 2500 to 3000 or 3500. It's better. 3500 ml is what we say to be the inspiratory reserve volume. Expiratory reserve volume, that is the additional volume of air that can expire by a forcible expiration, that is about 1000 to 1100 ml, 1000 to 1100 ml. Okay, so residual volume, the volume of air remaining in lungs after forcible expiration. Even after forcible expiration, even after the air is expired out, if any air is remaining there inside this lungs, it is known as the residual volume, and its quantity is about 1100 to 1200 ml. 1100 to 1200 ml. Guys, just note this. All these values are very important. All these values are very important. And do remember that in this session, when we took a session on this breathing and exchange, the previous one, we have did something else, that is how to calculate this tidal volume, inspiratory reserve volume. All those formula we have discussed. All those formulas we have discussed. You should note that. You should note that, because this year KVPY also for the essay stream, a question to calculate this tidal volume, calculate this breathing, what respiratory capacity was asked, giving breathing rate in percentage, giving breathing rate in percentage. So guys, you should know the each and every formula to calculate this. If I get time, surely I will show it today too. Okay, I will just show my class that lecture today too. Okay, so let me erase all those things. So all should by heart that how to calculate given example question, sir. Wait, let me search for that. Wait. Example means nothing more than this. Wait. Okay. So if a question may be asked, if a person has inspiratory capacity as what else? What to ask? If a person has inspiratory reserve volume, that we haven't learned. Yes, inspiratory reserve volume as 3000, and their tidal volume is 500. Find inspiratory capacity. It's a direct question. Giving inspiratory reserve volume and tidal volume, find inspiratory capacity. So how can we calculate the inspiratory capacity? Is it okay now, guys? Can you all hear? Is it okay now, guys? Can you all hear? Okay, fine. So let's continue with that. Hope it was from this respiratory volume, that is the problem, it was breaking. Hope it was from this respiratory volume, that is the problem, it was breaking. So let's do it. So come and write at the time when it's breaking, when the audio is breaking, okay? So the question that we have discussed was to find inspiratory capacity. Inspiratory capacity. Oh my god, where is this? To find inspiratory capacity, if the tidal volume is given as 500 ml and IRV, that is the inspiratory reserve volume, was given as 3000. So what is this inspiratory capacity then? Inspiratory capacity is the sum total of tidal volume and inspiratory reserve volume, and the answer is 3500 ml. Like this is a direct question that I have discussed now. Indirectly the questions will be asked for you in the examination. That is by giving the names of some persons. Some persons have what, some person inspire 500 ml of air, some person inspire 300 ml of air at a time during a normal respiration, and additional he inspires an additional volume of 3000 ml by a forcible inspiration. So what is this inspiratory capacity then? Like that, some twisted questions may be asked for the examination. So next is the residual volume that we have discussed, that is 1100 ml to 1200 ml. Okay. Inspiratory capacity, now we have discussed, that is the tidal volume plus inspiratory reserve volume 3000 to 3500 ml. Expiratory reserve capacity, very sorry, expiratory capacity, not reserve capacity, expiratory capacity. that is the total volume of air expired after normal inspiration. After normal inspiration, we will do a forcible expiration. That is what we say to be expiratory capacity. And your tidal volume plus expiratory reserve volume, that is 1500 to 1600 ml. 1500 to 1600 ml. Okay, guys, is the screen clear? Is the screen clear? Is the screen clear for you guys? Okay, Calvin. Functional residual capacity, that is the volume of air that will remain in the lungs after a normal expiration. Volume of air that will remain in the lungs after normal expiration is known as the functional residual capacity, that is the expiratory reserve volume plus residual volume. 2100 to 2300 ml, 2100 to 2300 ml. So next is the vital capacity, that is the volume of air that will remain, volume of air that a person can breathe in after a forced inspiration or breathe out after a forced inspiration. Breathe in after a forced expiration or breathe out after a forced inspiration. So the volume is 3500 to 4500 ml, and it is the sum total of expiratory reserve volume plus tidal volume plus inspiratory reserve volume. Total lung capacity, that is the volume of air in lungs after maximum inspiration. Residual volume plus expiratory reserve volume plus tidal volume plus inspiratory reserve volume, or vital capacity plus residual volume, that is about 5000 to 6000 ml. 5000 to 6000 ml. Clear with that? Clear with that? Moving on to the next topic, gaseous exchange. Gas exchange occurs by simple diffusion between one alveoli and blood, and second one, that is the blood and tissues. So this exchange between the exchange of gas between the alveoli and blood and tissues is known as gaseous exchange. Let me have some water, guys. Let me have some water. Okay, back. So alveoli, yes, hot water. Alveoli are the primary site of gaseous exchange, and the factors affecting this gaseous exchange are pressure or concentration gradient. Clear with that? So, what is this PO2? What is this PO2? So, as you all know, this alveoli are the primary sites of exchange of gases, and this exchange of gases occurs between the blood and the tissues. Also occur between the blood and the tissues. So, oxygen and carbon dioxide are exchanged in these sites mainly by what? Simple diffusion and based on the pressure or concentration gradient. Exactly, Calvin. Partial pressure of oxygen is what we see to be PO2. So the important factors that can affect the rate of diffusion of gases are, so the important fact, so this gaseous exchange occurs by what? They occurs by simple diffusion. So the important factor that can affect this gaseous exchange are solubility of gases. Solubility of gases. Second one is the thickness of membrane. Thickness of membrane in thickness of membrane involved in diffusion. Thickness of membrane involved in diffusion. These are the two factors that affect simple diffusion of gases. Is that clear? And the solubility of carbon dioxide is 20 to 25 times higher than that of oxygen. So solubility of carbon dioxide is 20 to 25 times higher than that of oxygen. Is that clear? So the amount of carbon dioxide that can diffuse through the diffusion membrane per unit difference in partial pressure is much higher compared to oxygen. So the amount of carbon dioxide that can be diffused through the diffusion membrane per unit in partial pressure is much higher to compared to that of oxygen, because the partial pressure of carbon dioxide is 20 to 25 times greater than that of oxygen. So what are the three layers that the diffusion membrane is made up of? The diffusion membrane is made up of the diffusion membrane is made up of three layers. First one is the squamous epithelium. Squamous epithelium of alveoli. Second one is basement membrane. Basement membrane. Is the screen clear, guys? Is the screen clear, guys? Is the screen clear? Third one is the endothelium of alveolar capillaries. Endothelium of alveolar capillaries. So these are the three layers in order to make this pulmonary. So the part is of oxygen. Okay, I can't hear. Will be clear. So stay tuned for that. And now I am winding up this session due to the network issues, and that's all for today. You hit the like button, do share it with your friends, and do subscribe the YouTube channel BioPoint Stream the World of Bio, and remark us by giving a comment in the comment section. Okay, guys. Thank you all. Thanks a lot. And now it's me signing out from your favorite and my favorite BioPoint Stream the World of Bio. Bye bye. Oh.